Welcome, meteorology students. This video is over temperature scales that we'd like you to know for class. So let's get started. Measuring the temperature has been something that people have been doing for many years, right? But we have three main scales. Here's the first one that you're probably the most familiar with if you're from this country. Fahrenheit, meaning Daniel Gabriel Fahrenheit, right? Came up with this method for measuring temperature. Water boils at 212 degrees Fahrenheit. Water freezes at 32 degrees Fahrenheit. Why do these numbers seem so strange and random? It goes back to what the scale is actually based on. I'm about to take you on a crazy trip, so just bear with me here. Here we go. 1714, he came up with a modern thermometer. It was a mercury thermometer, right? But it was taking its temperature based on an alcohol thermometer, right? Alcohol-based thermometer. And he marked 2 points on it, 0, and then 60 was the temperature where water boiled. 7.5 is the point where ice melted, and 22.5 was approximately where the internal body temperature was. Okay? So because the mercury thermometer was more accurate, Fahrenheit says, all right, let's take this scale, we're going to multiply everything by a value of 4, and he started to adjust those things, even putting the thermometer under his wife's armpit to try and get a more accurate body temperature. Okay? And then he says, all right, this initial scale, the 0 point, was going to be based off of ice mixed with water and mixed with salt, right, or an ammonium chloride. And then that stable temperature there we're going to call 0. Then he says the second point is going to be 32. This is a mix of ice and a mix of water. The third point was 96, approximately where he thought the internal body temperature of a human being was. They called that blood heat, right? And by the end of it, I'm wondering, where in the world did this come from? All right? And where is it used? Well, mostly in the United States. If you grew up in the US, then you're probably familiar with Fahrenheit. And really, the only reason that the Fahrenheit scale makes sense to you is because you've got experience with it. You understand, and when somebody says it's going to be 75 degrees outside, you've been outside on a day that's 75. Or when someone says that water boils at 212 degrees Fahrenheit, you can think of the last time you put water on the stove and cranked up the heat, right? Hopefully you didn't feel how hot that water was. We have experience with this somewhat strange scale, and it just is not used widely throughout the world, believe it or not. Most of the world does not use the Fahrenheit scale. Most of the world uses the Celsius scale. So thank you, Anders Celsius, for this one. This one makes a little more sense to me. This Celsius scale is based off of water. Where water melts, right, and freezes, he called that 0. That was kind of a base point. And then decided that when water was boiling, he would call that 100. So that there were 100 units of measurement from where water would freeze or melt to where it would boil. And that's it. No armpits, no salt water, no nothing. Every 1 degree on the Celsius scale, though, is not the same as 1 degree on the Fahrenheit scale. They're different. They don't play particularly nice with each other, right? So where does this scale get used? Pretty much all over the entire world. It's a pretty long list compared to the Fahrenheit one. Lots of countries are using the Celsius scale, and in the world of science, regardless of which country you're in, we use the Celsius scale quite often. There's a third one, thanks to William Thomson, also known as Lord Kelvin. This one is called the Kelvin scale. It's based off of molecular motion. How fast are molecules actually moving, right? When things get cold, molecules will slow down and the temperature drops. So in theory then, if you could get molecular motion to stop altogether, then we call that 0 Kelvin or absolute zero. When you compare it to the Celsius scale, okay, no molecular motion, absolute zero, is 273.15 degrees Celsius negative, right? Negative 273.15. It's incredibly cold, extremely cold. So who uses this one? Nerds, that's who. That's not fair, I'm just kidding. Scientists, the world of science, right? When research is done, we use Kelvin and we use Celsius, and in the world of chemistry, it's used quite often. Now, the nice thing about the Kelvin scale is it plays very nicely with the Celsius scale. Even though 0 degrees Kelvin is negative 273.15 Celsius, if you go up 1 degree Celsius, that's equal to 1 degree increase in Kelvin as well. So they move along their scales very nicely and play very easily with each other. All right. Here on this slide, you got to dwell on this one a little bit. We're going to teach you how to convert temperatures from Celsius into Fahrenheit and Fahrenheit into Celsius, because when we live in America, we have to be able to communicate with the scientific world, and then also with people in other countries. So here's the basic idea. If you know the temperature in Celsius, which most of the time we probably don't start that way in the United States, here's the process, okay? You take 9 divided by 5, you multiply it by whatever your temperature is in Celsius. Here they're using 35 as an example. And then the very last step is you add 32. All right? If you want to go the other direction, if you know the temperature in Fahrenheit and you want to get it in Celsius, then what you do is you take that temperature in Fahrenheit, and the first thing you do is subtract 32. And then you multiply it by 5 and divide by 9. Okay? They're two mirror images of each other. They're opposites mathematically. And so we'll practice this today and down the road as well. And on your upcoming test, you'll be expected to be able to do these conversions, taking a Celsius temperature and turning it into a Fahrenheit temperature, and then taking a Fahrenheit temperature and turning it into a Celsius temperature.